This is the brief on dimensional analysis. The secret weapon for turning specific physics problems into universal laws. We're going to dive into how this process takes complicated, real-world problems, like how heat flows through a particular material at a specific temperature, and turns them into these highly efficient, generic solutions. First, you've got to understand the limitations of working with physical variables. When you measure things in, say, meters or degrees, your results are tied to that one single scenario. Change the starting temperature, change the material's thickness, and boom, your whole plot is useless. That specificity means you're just constantly running new tests. So how do we fix this? Well, that's where dimensional analysis comes in. It's the mechanism that converts those specific quantities into universal, dimensionless forms. The analysis basically finds the system's inherent rules and uses them to create a standardized measuring stick. This scaling transforms a complex, parameter-filled equation into a simple, pure numerical pattern. And the payoff is incredible efficiency. Dimensional analysis takes the complexity from tracking 5 different physical settings down to managing just 2 universal ones. You go from an infinite number of solutions to a single, generic curve, a universal fingerprint of behavior. This view isn't just computationally superior, it offers deep physical insight, like the diffusion rate we see in the dimensionless time, known as the Fourier number. Dimensional analysis is the core transformation that allows one physical test to define the behavior of every system in its entire class.